Hello, we'll see today previous year questions of strength of material from engineering studies. Okay, this will be for especially for mechanical engineering and civil engineering background. Okay, today we are going to see the questions of bending moment and shear force diagram. Okay, this is about myself. I think we have solved already a lot of questions. This is the question number 31 for engineering services. So if you have not watched the previous lectures of strength of material, please watch those videos as well. There is I think already 27, 28 lectures I have already uploaded. So here they are asking for, we'll read, a beam built into two ends, okay, carries uniformly distributed load, okay, UDL is given. So they are asking the bending moment diagram. Okay, don't read these things. Okay, just see the loading condition is given UDL and they're asking what is the BMD for this loading condition. Okay, so this one A, B, C and D. So for this kind of loading for UDL, this is nothing but is the D is the BMD is direct expression. Okay, once I will deal the SFD BMD for different loading condition, we'll see this. So as of now, just remember for this UDL which is fixed from both the side, this is the BMD. Okay, so the answer is next question. The point of contrafracture is a point where, okay, shear force changes sign, bending moment changes sign, shear force is maximum, bending moment is maximum. So this is actually B. Okay, the point of contrafracture is the point where bending moment changes its sign. Okay, so suppose in the GATE exam or in the engineering services exam, they will give you some loading, some bending moment diagram. So they will ask you A, B, C, D, at which point it is a point of contrafracture. So you have to see where the bending moment is changing its sign from positive to negative or negative to positive. That point will be the point of contrafracture. Okay, so the answer is B. Please remember that. We'll see this point a lot of in many of the problem once we'll deal the SFD BMD for in the complete lecture series. Next question. Okay, they are asking a bending moment is constant. Bending moment is maximum for maximum or minimum. Bending moment is 0. Loading is constant. Okay, so these are the point of contrafracture, shear force changes sign, slope of shear force diagram is 0 over the portion of BEM, shear force is 0 over the portion of BEM. So we have to match with these. Okay, we'll see. Bending moment is constant. It is for shear force, slope of shear force diagram is 0 over the portion of BEM. Okay, bending moment is maximum or minimum. This is nothing but point of contrafracture. Okay, no, this is not a point of contrafracture. Bending moment of maximum, minimum, this is actually this one, shear force changes sign. Okay, and actually the point of contrafracture is what, where the bending moment changes its sign, is not maximum or minimum. Okay, so at actually this is the point of, obviously at that point bending moment will be 0. Okay, so point of one more way of saying point of contrafracture where bending moment changes its sign as well as bending moment is 0 at that point. So it is actually bending moment 0 at that point, it is 1. That is point of contrafracture. Okay, and rest one is, this will match with 4. So loading is constant, shear force is 0 over the portion of BEM. So the answer is B. Okay, so this is the thing. This is actually a good question. So if you have very good idea of SFD BMD, then only you can answer this question. Anyway, they are asking, this is the loading condition. I mean, this is the BMD. This is the BMD. Okay, so they are asking what is SFD. Obviously, for this BMD, what is SFD out of these four? So it is actually, for this is SFD is B. Okay, if shear force is 0, bending moment will also be 0. If shear force varies linearly with length, bending moment will be curved. Okay, so that's why the answer is B. Okay, so for this is nothing but is bending BMD. BMD is given, so they are asking SFD. Okay, shear force diagram. So obviously, so we have to choose out of these four, whether this, 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 or this. Okay, it is actually A. Its answer is A. Again, I have mentioned this thing many times. You please remember this will be the answer. I know the answer. You also know the answer after watching this video. I will do complete lecture series. We'll see all kind of loading conditions where how to draw the SFD and BMD. Once you watch those things, I think many of you already know that, but if you don't know, just wait for few months. Okay, not very long time. You will become the master of how to draw the SFD and BMD. So as of now, for this BMD, this is the SFD. Next question, obviously, this is SFD. Okay, shear force diagram for ABCD beam, for this beam. So bending moment diagram in the portion of BC. So for this portion, they are asking what is the bending moment in this region. Okay, is non-zero constant, is zero, is varies linearly from B to C, varies parabolically from B to C. This is actually is non-zero constant. Okay, the answer is A. So for this reason it will be non-zero constant. Okay, next okay, figure shows above represent the bending moment for simply supported beam. The beam is subjected to which of the following? So this is actually bending moment diagram is given. So they are asking the beam is subjected to what type of loading. They are asking actually what type of loading. So concentrated load at its mid length, uniformly distributed load over its length, a couple at its midpoint, a couple at 1/4 of a span from each end. So in this bending condition is nothing but it is a couple of its mid length. You can see here M is given. Okay, this M is given. So from here itself you can get a clue. This will be a couple. Okay, so a couple at its mid span. So the answer is C. Next question. Again, the BMD is given. The BMD is given. Asking then the load acting of the beam is. Okay, so what type of load is acting on the beam is a concentrated force at C, a uniformly distributed load over whole length of the beam, equal and opposite moment applied at A and B, a moment applied at C. Okay, so they are asking about the load. What type of load is acting in this kind of BMD condition? So this is actually a movement applied at C. Okay, so if you remember the previous question, it is the same problem. Okay, so the answer is D. Okay, a vertical line of center of BMD is possible when the moment is applied there. Okay, so here is M, here is M. You see the previous question, it is the same question. It's nothing but is the same question, the previous question. Okay, so here what is given? BMD is given. Okay, for the CABD beam, they're asking what is the loading condition. Okay, for this, what is the loading condition out of these four? Whether this, or this. See, I will if the BMD is linear, okay, if BMD is linear, then load will be constant, and if BMD is parabolic, then it will be UDL, okay, uniformly distributed. Like this, if you know these 2 points, you can answer this question. Okay, so for you can see at point C to A and B to D, it is a linear, so there will be constant load, and this is in between A to B, it is parabolic, so it will be UDL. The answer is A. Fine. So the answer is A. You can just read this. It is the same thing written which I have told you. Okay, for linear variation, constant load. For for parabolic distribution, it is uniformly distributed load. So the answer is A. Next question, SFD is given. Okay, so in following figure, so I think they are asking the type of loading: simply supported beam, which with symmetrical point, load about mid-span. Okay, so obviously they are asking the loading condition for this SFD. So it is actually for this, it is a freely supported beam with symmetrically uniformly distributed load over the mid-span. You can see here, you can see this portion, you can see this portion. Both are symmetrical to each other. Okay, symmetrically in up. For the feet, it is like you can say the area. Its area is almost similar, same. So it is nothing but it's a freely supported beam with symmetrically uniformly distributed load over mid-span. Okay, so the answer is B.